All right, so one more example to get us through the general form. This problem is Ake has a 60 centimeter ribbon that they're cutting into 5 pieces. 2 of those pieces, they're going to be the same length, and the remaining 3 are going to be of another, which is also going to be 3 of the same length. I want you to show me some possible lengths, then I want you to graph the data to prove that it's a linear relationship. And lastly, I want you to write the equation of a line in general form. Okay, so this is a bit of an involved problem. It's not too difficult once you understand what to do with it, but the hard part is where do we start, right? So the first thing that I've done is I've determined an equation that I can work with. I have 60 centimeters, which is my total. So if I add up all my other pieces, I should get 60. I know I have 5 pieces in total, and 2 of them are the exact same length. I don't know what that length is, so I'm going to call that x, 2x. I also know that 3 are also the same length, so I'm going to call that second length y, which is 3y. And those are the only 2 possibilities I can have. So when I add 2x and 3y together, I should get 60. The next thing that I've done, and it's not going to help me with part A, is that I've determined my intercepts. The reason why this won't help me with part A is because I'm indicating that my x value is 0 or my y value is 0. If that's the case, it means that one of our pieces is of 0 centimeters, which means the piece doesn't exist. So that doesn't help us with part A, but it gives us some points for part B. So that's going to help us when we graph. Before we get there, let's figure out what some points could be, though, for part A. In order to do that, now that we have the equation, we can pick some nice numbers that are not going to be zeros, and that'll give us some pieces that actually work. So to determine valid points, you can pick any number you want to replace x or y with. I spent some time to pick some nice numbers so it works out. Might not always work out, but it'll always give you a solution that is valid. So I chose 18 to be my first x value. The reason for that is 2 times 18 gives me 36. When I rearrange the equation, I get 60 minus 36, which gives me 24. 24 is equal to 3y. Divide both sides by 3, I get y is equal to 8 when x is equal to 18. We can always plug those numbers back into our original equation just to see if they actually work. So if I had 36 plus 8 times 3, which is 24, I end up getting 60, it works, right? We can do the same thing with another point. So if we want some extra data, I chose my x value to be 24. So I end up getting 60 equals 48 plus 3y. Subtract 48 on both sides, you get 12 equals 3y. Divide both sides by 3. You end up with y equals 4, x is equal to 24. So works both ways. So that's how you can generate some data that works. You can still use your intercepts to help you understand where the line is, but remember, you have to follow the logic of the question as well. So now let's graph it. Okay, so to graph it, we're just going to be putting our intercepts or the points that we've calculated on a graph somewhere. Just be careful that you're following the logic, right? These points, these intercepts, cannot exist on this graph because it means that the ribbon has 0 value in some pieces, which can't exist. So we're going to put open circles, if you remember what that is from inequalities in grade 9. If not, it's okay. So at y equals 20, which is over here, x is equal to 0. So I'm going to put an open circle. Also, by using logic, I know that all my values have to be positive, so I'm only drawing this quadrant of the graph. If you recognize that, great. If not, that's not an issue. My other point is when y is equal to 0, my x value is 30, so that's over here. Okay, again, it's an open circle because those points cannot exist. If you don't like using that, use the other points that you solve for. Y is 8. This is 10, it's somewhere around here. X is 18, should be somewhere around here-ish. The other one that we solved was y equals 4. Y is, well, if that's 10, 5 would be halfway down, 4 is about there, 24 would be halfway between, should be somewhere around here. So you can see that the lines still kind of match up. You can draw your line in. Please use a ruler, otherwise it's not quite proper. But yeah, it is a linear relationship. Okay, so a bit of practice to get the graph in place there. A few parameters and a few little logic pieces to watch out for, but that's how you would work with that. The last step is to write the equation in general form. Let's do that on the side. Well, as it turns out for this question, it's actually pretty straightforward. We're very close to general form. We're in standard form where we started off with. Standard form is really nice because your C value is your isolated value. So if you take the inverse of that, you end up getting general form. So by subtracting 60 on both sides, I get an isolated 0, which is what I want for general form. My x value comes first, so my ax is 2x. My by is positive 3y. And my c value is negative 60. That would make general form. So how's that for a lot of work? Yeah, that's our equations of lines. So there's 3 of them. I'm going to give you a ton of practice so that you can jump through and start practicing your conversions and such. As always, give me a shout if you have any questions. We will continue on with the second part of the unit. So the systems unit will merge into this one. You'll see that they work really well together. So we'll continue that. If I assign a review, don't freak out. There's no test coming right away. You'll have an assessment coming up a little bit later on. All right, hope you guys are having a good one.